All right, so now moving on to our next unit, which is Unit 5, and this unit is going to focus on functions. And you're going to learn that we actually have been dealing with functions all along. We just never gave them this fancy name for it. But all the linear equations that we've been solving and graphing, they're all functions. And you're going to identify and understand why by the end of this unit, and hopefully even by the end of the next couple videos. But we're going to be on, so we're doing our first video, so video A. And this video is going to be broken up into two different videos. And video 1 is going to focus on the first 3 learning objectives, while video 2 will focus on the last 2. And this section is going to be about functions and being able to identify what are functions. And then also, more specifically, we'll talk about the domain and range of a function because they help us to determine if a set of points or if a graph is actually a function or not. So what you're expected to know by the end of this video, or not necessarily know, but just have an idea on, is, well, first, what is a function? What makes up a function? And what is the domain and range of a function? So when we talk about a function and I ask you to give me its domain or give me its range, you'll need to be able to know how to do that. And then also on top of that, you'll have to know what are dependent and independent variables. All right, so that's what you'll need to know by the end of this video. And then we'll move on to our second video, which will cover the 4th and 5th learning objectives on this. All right, so let's go ahead and start talking about what is a function. So what is a function? Well, a function is a relationship that pairs each input with exactly one output. So that's the main thing you have to remember. And we're going to talk about what it means to be input and output. But just remember that each input that you have gives you exactly one output. So you can think about it in terms of like a vending machine. When you go into a vending machine and you put your money in there, or you swipe your octopus card and you type in D4 because you want that drink or whatever it is that you're getting, the vending machine knows, okay, when they type in D4, this is exactly what they want. Imagine if you went into a vending machine and you typed in D4 and it didn't know what to do, or it actually gave you 3 or 4 different things. Well, when we have a function, it's like the vending machine where we have an equation that, or we can imagine our vending machine is the equation, and we're going to say, okay, well, we're substituting this in for x, and then the vending machine runs through we do the equation, and then it pops out one number for y, or the vending machine pops out one drink for you. So we can think about that in terms of a function, because if we try to say, okay, well, when I substitute in x and it gives me 2 or 3 different answers for it, well, how do I know which one I would use? So see, it would cause some confusion and will cause some, well, what do we do in this case? Same thing with the vending machine. If you can go in and press D4 and it's going to give you a soda and a water, well, it's going to be confused on which one to give you, and that vending machine would run out of money, or would run out of business because they wouldn't be getting all the money they need every time for the drinks that they're actually giving people. So we can think about our function as a vending machine, where when we input something, it gives us exactly or one thing in return, exactly what we want in return, if you want to think about it like that. And if we were to have an equation where we can plug in an answer that gives us, or plug in an x that gives us multiple answers, well, how do we know which one to use? So that's what we can think of as a function. That everything that we input gives us exactly one output. So for every x that we give us when we plug it in, it gives us one y in return. All right, so our inputs here are our x values, what we're substituting in for x. Because if we think about the equation, if we go to try and solve for this, and we've done this throughout this year already, if we want to try and do anything with this, we're saying, okay, well, if x is equal, like when you think about the word problems that we solve, we always then substitute in for that x. We're not substituting in for what the equation's equal to. We substitute for our x value, or what we can input. All right, so just remember, a function, and this is the main thing, a function is a relationship that pairs each input, so each input, with exactly one output. So when we substitute in for x, there's no um, questioning about what the value will be. We get just one in return. So if you look here, we have the equation y is equal to 3x, and this is a function. And we have the equation y equals 3x. And if we input -2, well, -2, when it goes into this machine, just like our vending machine, and it goes through 3 times x, it's going to give us the output of -6. So it gives us this one number in return. There's nothing that we can do where we plug in -2 and we're like, oh, is it -6 or is it +4? Right? It's just that -6. And same thing, if I were to substitute in this -1, well, this is going to give me -3 in return. If I were to go ahead and substitute in 0, well, 0 is going to give me 0 in return as well. If I go to plug in 1, Well, 1 is going to give me 3 in return. So you see, all of these give us that one answer every single time. But let's just imagine, now we know this isn't true, but let's just imagine when we plug in 2, for some reason, this generates two numbers. It generates a 6 or it generates an 8. Well, how would we know which one to use? That's where it would cause some confusion, like in the scenario I gave you with the vending machine. All right, so our functions are a relationship that gives us 1 for each input that we substitute in. So for each x value that we substitute in, we get exactly 1 output in return. All right, we know that when we plug in 2, it would give us 6, but I'm just giving you an example of when it would cause some confusion if it gave us these multiple answers. All right, now we're going to talk about how we can also represent these x and y values and other names that we can give these input and outputs as well. But what you have to just remember with this, that with a function, this is what's really, really important, is that for each input, there's exactly 1 output. So there's no confusion. When we plug in something for x, it's not that, oh, it can be this number or this number. It must just be 1. So every single x can only have 1 y associated with it. And then to talk about some other ways that we can refer to these inputs and these outputs, I'm going to erase this just so it gives me a little bit more room to write. Is another way that we can refer to our inputs are our domain. So when you hear me talk about our domain, we're talking about our x values. So we're talking about what we can put into our equation. And then if you hear me talk about range, range is our output or our y values. All right, so when we talk about our domain, it's what can we substitute in? Because whenever we have a function or equation, we're going to substitute in our in for our x, and then our domain is what we can input, and our output is our range. So our x values are all of our range, or all of our domain, and our y values are all of our ranges. So this is something you're going to have to just know, because some questions on your test are going to say identify the domain and range of this problem. So you have to know that our domain is our x values or our input, and our range is our y value or our output. So in this question here, just because we're doing this a very finite set, our domain would be -2, -1, 0, 1, and 2. And our range would be -6, -3, 0, 3, and 6. So our range is our y values and our domain is our x values. All right, so we can also just say our domain is our input and our range is our output. All right, so those are some of the things that you need to know about this. And now we're going to discuss a few other things and some examples in this problem, in this video as well. All right, so for this problem, we're asked to find the domain and the range of the function represented by the graph. So if we want to go ahead and solve this and find a domain and range, what we need to do is identify the x and y values for each point. So when I see this point here, I need to write that as its ordered pair. So that is at the point of -3, -2. And then my next point here, my x is -1, my y is 0. So then it's -1, 0. My next point is at 1, 2. And my last one is at 3, 4. So these are all the points that are represented by the graph of this function. So if I want to find a domain and range, well, I know that my domain are all of my input or all of my x values. So here's my domain. So I would just simply say that my domain, and then this brace represents the set. So it's the set of -3, -1, 1, and 3. And then I can go ahead and know that my range is all of my y values. So all of my y values are here. And I can go ahead and write that my range is equal to -2, 0, 2, and 4. So this is my range and this is my domain. We are going to go into this in more depth in the next part of this video, and also in our later sections as to when we actually draw a line connecting these. There's a big difference in what we're doing there versus when it's just individual points. All right, but for now, if you're just given individual points like this, that is just our graph that we have. And since there's no line drawn in between them, we're not worrying about this point here or what would happen here if we were to draw those lines, because we're focusing on just the graph here, which is just those points. So in this case, we have a domain of -3, -1, 1, and 3. And we have a range of -2, 0, 2, and 4. And you see, we only had one possible y value. When we did plug in 1, there was only this one value of y that we can get in return. There wasn't another point down here that said, oh, well, when we plug in 1, we could also be -2. All right, so for every one x that we have, there is only a one possible value of y in return. All right, now the next thing that you need to be able to identify is what are dependent and independent variables. So when an equation represents a function, the variable that represents the input values, which we know is our x, they are our independent variables because it can be any value in the domain. So let's go back to this example of y equals 3x. Let's just say that we're selling pies for $3. All right. And we're trying to figure out, well, how much money can we make if we sell 20 pies or 22 two pies? So in this case, you see how our amount of money that we make would represent y, and x would represent the number of pies that we sold. And since our total money, that's what that's supposed to say. Let me just write that a little bit neater for you. Since our total money that we're making is relies on how many pies we sold. So you see, this y value is relying on how many pies we sell. So pies aren't relying on anyone except for someone wanting to come up and buy them. So we can have 5 customers come today, we can have 10, we can have 6, we can have one customer come today that buys 50 pies as well. So you see, the amount of pies that we sell are not influenced by the total money that we have, because we're not saying, oh, okay, we have $1,000, so now let's sell these pies. No, it works in reverse. We sold this many amount of pies and we made $1,000. So you see, because this x value, what we substitute in our input, is independent, and it's not affected by our y value. That is our independent variable, because we can do anything. If we're talking about, maybe it's how long it takes for you to walk around a block. Well, how long are you going to walk for today if you walk 10 blocks? So you see how what we're substituting in is independent, because it's something that we can either, in some scenarios we can choose whatever numbers we want to substitute in with, or in some of them it's how many people actually literally bought the pies. But those are all independent because nothing affects those. Whereas in this equation, once we know what we're substituting in for x, then that is going to affect the amount of money that we have, or the amount of how long it took for us in total to walk around the block. All right. And then the variable that represents the output, which we know is our y variable, is our dependent variable because it depends on the value that independent. If I said, okay, how much money did you make when we sold 10 pies? We need to know how many pies we sold. And then 10 times 3 will give me $30. If I said, okay, well, now what about 50 pies? We'll see how the y value is dependent upon what we substitute in for x. All right, so that's why we can think of it as our dependent variable for our y and our independent variable for our x. So what we will need to do in this, all right, we have our x and we have our y. We know that our x is referred to as our input, and we know our y is referred to as our output. We also know that our x is referred to as our domain, and our y is referred to as our range. And then our x is our independent variable, where our y is our dependent variable. All right, there's one more example we're going to go through in this video, and that is it, I believe, after we go through that last example. All right, so for this example, it says the function y is equal to negative 3x plus 12 gives the amount of y in fluid ounces of juice remaining in a bottle after you take x gulps. So the question asks us to identify the independent and the dependent variables. So they do tell us that x represents gulps and that y represents the number of fluid ounces that are left in remaining in the bottle. So it's telling us what it is right off the bat. But let's just talk about why. So if you have a bottle of juice, you just bought it, and you go to drink, well, the amount that, if you haven't drank anything yet, well, the juice is still completely filled. So if you start drinking from your bottle, that's going to then lower the amount of juice that you still have in there. So you see how what you are drinking is affecting what is left in your bottle. Therefore, what's left in your bottle is dependent on how much you're drinking in each of your gulps. So in this case, our independent variable are the independent variable. The gulps are the independent variable because, hold on. Are the independent variable because how much you, first off, you can decide how many gulps you want to take. If today you're like, I'm not going to take any gulps, well, see how that's independent, like there's nothing that's really affecting the gulps. Yeah, you are affecting that, but you're not part of this equation. So if we decide, okay, I'm taking 2 gulps right now or 3 gulps, that's dependent or independent completely on whatever you want to do when you're drinking. So the gulps are the independent variable because we can do any amount of gulps that we want as well. We can take 1 gulp, 2 gulp, 3 gulps, 4 gulps. We can do whatever we want with those gulps. And then what's dependent is the amount left. So juice remaining, or our y value in this case, as they tell us here, y, is the dependent variable, because however many gulps we take is going to affect how much juice is remaining. We can't just say all of a sudden now, oh, well, I want to have half of this juice remaining without taking any gulps, unless we're poking holes in it or dumping it out, which is then completely changing this problem as well. Our juice is completely dependent on how much we are drinking. All right, so you see how that is dependent? So our x value is always our independent variable, and our y value is always our dependent variable. So here's our x, and here is our y. All right, now for problem B, it says, given the domain of 0, 1, 2, 3, and 4, what is the range? So now they're saying, okay, these are the amount of gulps that we're focusing on. And when we focus on that, what is the range? So we're going to create a table here, x and y, and I'm going to plug in the points that they want me to substitute in for x. So we have 0 through 4. And now when we substitute it in, we're plugging it into this equation. We're substituting into y is equal to negative 3x plus 12. So now when we plug in 0, we get y is equal to negative 3 times 0 plus 12, which we know is going to be equal to 12. So when x is 0, y is 12. When we plug in x is 1, so when we take 1 gulp, we then get negative 3 plus 12, which is 9. So now we have when x is 1, y is 12. We'll plug in 2, we'll plug in 2 for our x, so negative 3 times 2 plus 12. So this is then going to give me 6. And then we'll plug in 3. Let's use a different color. Purple. And then I'll do the next one up here. Y is equal to negative 3 times 3 plus 12, which is then going to give me 3. And then our last one that we have here for 4, let's just do blue. Y is equal to negative 3 times 4 plus 12, which is equal to 0. All right, so now in order for us to find a range, we need to actually plug it in and say, okay, well, what is our y values for each of these x's? So our range is going to be equal to the set, remember that step brace, of 0, 3, 6, 9, and 12. So that is our range for this problem. All right, that is it for this video 1 of this section.